Title of the subject is electric circuit analysis. Electric circuit analysis 18E32. Okay. So first we will be knowing what is electric circuit. Electric circuit is one that will carry the electric current. Very simple. Okay. Electric circuit is one that will carry electric current. Now, why the electric current has to be carried in any circuit? Okay. To do some work. Okay. Electric current has to be carried in any circuit to do certain work. What is that work? That work can be running a motor. That work can be giving a light by illuminating the lamp. That work can be heating the element. That work can be transmitting the signals from one circuit to other circuit, that is communication. That work can be transferring the power from one circuit to other circuit, like in transformers. Okay, so in any electric circuit, when we say the work is done, it is done when the current flows in that circuit. When current doesn't flow in any circuit, or when the current is not made to flow in any circuit, work done in that circuit is not attained. Okay, so it is the current that is doing work in almost every electrical system. If there is no current, then it is very hard to say that a work is done by a electrical system. Okay, so what is all about electric circuit is, it can be a series circuit, parallel circuit, combination of series, parallel, active circuit, passive circuit, AC circuit, DC circuit. Ultimately, it has to carry current. That's it. If any circuit that is not carrying current, we simply consider that circuit to be of no use in our analysis. So what we are doing electric circuit and analysis. What analysis we are doing? We want to know what are the electrical quantities across each element or through each element, or the electrical behavior of the entire electrical circuit. It is very primitive statement, but when you see in a large view, ultimately I want to know what is the characteristic relating current and voltage. These are my requirement. I want to characterize the circuit in terms of voltage and current. Automatically we'll get to know what about power, energy and everything once I know what is voltage, what is current. Okay, so what is my main intention in circuit analysis is to find the currents and voltages in the branches or at the nodes. Voltage will exist. If I want to know what is the voltage, we'll get the voltage at a node or across the element, and current through the branches. Okay, so in some circuits I may be knowing the voltages. I want to know what is the current. In some circuits I may be knowing the currents. I want to know what is the voltage. Once I know what is voltage and current, I may also be intended to know or interested to know what is the power, what is the energy, and what is the characteristic between V and I across certain elements and all those things. So that is all about analysis. To know, analysis is to know the nature, to know the behavior. That is analysis. What nature, what behavior? Behavior of voltage with respect to current, or behavior of current with respect to voltage. That is what I want to know in this analysis of electric circuits. Okay, so we know that electric circuit is simply a connection of electrical elements. Later we will categorize it as active element, passive element, okay, AC element, DC element, all those things. But in general, what is electric circuit? Electric circuit is that which is the connection of physical connection of electrical elements. And what are electrical elements? Resistor, capacitor, inductor, voltage source, current source. I will put a star for that current source. When I go to current source, I will tell why that star is been put. Okay. Current source, it may be diodes, semiconductor devices, it may be machines, it may be any heating element. Okay, all these will form electric circuit. Anything that is connected to make the electricity flow is electric circuit. So that is my electric circuit. Okay, and in this electric circuit, the sources play a vital role, because unless and until I have the sources, I don't get the voltage and current in the circuit, because there should be something which is giving out these voltage and current. So the source that is giving out the voltage is voltage source. The source that is giving out the current is called current source. This is very much understandable. Okay. So these sources are the elements that will give out the power, that will give out the energy. Okay, you can interchangeably I will be using power and energy. Okay, so don't get confused with that. Okay, so the source is providing the current or the voltage, because unless and until I have the current and voltage across my elements will not work as per the desire. Okay, so here the sources can be voltage source, it can be current source. Okay, it can be a voltage source, it can be a current source. Okay, so what is voltage source? Voltage source is that which is characterized by the voltage across its terminal. So voltage source is one. The source characterized by voltage across its terminal. Across its terminals. Current source characterized by current through it. So I told that I will put a star mark on the current source. Okay, I will put a star mark on the current source. Okay. Why I will be putting a star mark there? Because practically getting a current source completely without the help of voltage source is difficult. A current source is obtained by converting a voltage source to get the constant current. See, what is a source means? Characterized by voltage. Here I told voltage source is the source that is characterized by voltage across it. What does that mean is, at any point of time, if you check the voltage across that voltage source is same. Now take a battery, open it from the packet, you check, it will be of 1.5 volts. Suppose it is a AA battery, okay, that we use in our wall clocks, in our mouses and all. If you take a AA battery, it will be of 1.5 volts. Now after 2 hours you check the voltage, it will be of 1.5 volts. After 10 days you check, it will be of 1.5 volts. Even after you use, when I say the battery is discharged, even if you check the voltage, it will be slightly less. It may be coming down to 1.4 or 1.3 volts. But the current delivering capacity will be lost when the battery gets discharged. It is due to the deterioration of the dielectric material that I use in the battery. Okay, that is called discharging of the battery. Okay, it is not that voltage becomes zero. No, voltage will remain same, but the current delivering capacity is lost because the charges held by the dielectric material inside the battery. If you break a battery, you see a black powder. That is a dielectric material. Depends what type of battery I will be using. So the charges held by those will be completely lost. So therefore, I don't get a dq by dt in that battery. That is dq by dt is what? Di. That is current. Okay, when the flow of charge is lost, flow of current is lost, but the voltage will remain same. So that voltage is the source value of that source. Okay, value of that source. But what about current source? Current source is practically not independently is not realizable. If I want a current source is what? It is a source or the element that gives out a constant current. That is my current source. If you remember the transistor operation, okay? If you remember a transistor operation, when the transistor is operating in active region, okay, we say transistor is operating like a current source. Because if you see the VI characteristics of a transistor, it will be like this. After some this point, this is IC and this is VC at various base currents, IB1, IB2, IB3. So this is all what my active region, is it? So in the active region, the transistor is operating like a current source because see, even though there is variation in the voltage, my current IC is remaining constant. So a current source is a source that will deliver a constant current. But it is practically difficult to get. It has to be characterized through the voltage. Okay, because there can be voltage without current, but it is difficult to get the current without voltage. If there is no electromotive force, motion of electrons is difficult to achieve. So therefore, current source is realized through voltage source. Practically, I am talking. Practical current sources are difficult to obtain. If you remember in our regulated power supplies in our electronics laboratory, there is a changeover switch in the front panel of that regulated power supply. You can choose for volts and you can choose for amps. If you choose for volts, it will give out the voltage. If you choose for amps, it will give out the current. So the same source is converted to the same voltage source is converted to a current source simply by adding a resistance in parallel to that. If across voltage source I add a resistance parallel to that, it becomes a current source. So current source is realized on paper, okay, to understand the concepts, okay, but practical building of current source will be through voltage source only. Okay, so these are the two main sources in an electric circuit: voltage source and current source. And these voltage source and current source can be dependent or independent. Okay, it can be dependent or it can be independent. First, it can be ideal or practical. Simple. First, we'll see that ideal or practical. Okay. In ideal, internal resistance is 0. Here we get some internal resistance. Okay. So ideally, there will be no internal resistance. It means that if there is internal resistance, there is a small amount of voltage drop in the voltage source itself. Okay. a small amount of voltage drop in voltage source itself. You can very conveniently realize this using a generator armature. Now always when I take a generator, I add some resistance RA in series to that. So the generated voltage is suppose in 100 volts and it is having some 1% drop. What is the terminal voltage I get here? It is 99 volts. Now ideal generator, my resistance will be 0. So this is the internal resistance. So when I build a source, inherently, implicitly, there will be component resistance values added to that source. Therefore, the grand terminal voltage, what I get, may be slightly lesser than the actual generated voltage or actually charged voltage. Fine. That is called practical source. Okay, so practical source will be having some internal resistance in it. We'll look into that. Okay. Whereas an ideal source, no internal resistance. Okay. Then the sources can be independent sources or dependent sources. Independent source, dependent source. The name themselves are suggesting their nature. So independent source, the source value doesn't depend on anything. Okay. Source value, okay, do not depend on do not depend on you can call other circuit parameters, other circuit element parameters. Whereas in dependent source, source value depend on other circuit element parameters. Okay. Other circuit element parameters. So those are called independent sources which have got their source value independent of any circuit parameter. If the source of the value of that particular source is depending on the some other circuit parameter, it is called dependent source. We will get both the kind of sources in our electrical circuit. We will get both the kind of elements in our circuit, though may not be completely observed as sources, but certain elements will behave like sources. So for example, when a capacitor is charged, it starts behaving as voltage source. Okay, when the capacitor is charged, it starts behaving as voltage source. Now the charge on the capacitor is depending upon the current flowing through that capacitor. I am giving just an example. Okay, so you don't think that this is the case. Now, for example, suppose I have a some circuit I have. Okay, suppose this is source voltage. I have some element here, some element here. So many connections are there. Now, suppose I have a capacitor here. Okay, I have a capacitor. Resistance is R. Capacitor is C. Okay. Now, when this branch carries current, let me take it as IC. We know that this capacitor will charge. We know that this capacitor will charge. To what value of voltage will it charge? It will charge to dV is equals to 1 over C, or V is equals to, don't worry about the equation values, just remember this. V is equals to 1 over C integration I C dt. Okay. don't worry about the equation, how it came all, you don't worry, just remember. Now see, the voltage across capacitor VC is depending upon the current through this capacitor. Now can I say this voltage capacitor is, or this capacitor voltage is dependent on current IC? So this will become a current controlled voltage source. Is it? This will become a current controlled voltage source. Fine. Now I am not defining this as a source. This is a passive circuit element. But when it charges, it may behave as a source. When it charges, it may behave as source. Okay? Because when it charges, it has to discharge. It means that first it has taken the current in, and while discharging, it is giving the current out. So the thing that is giving the current out is a source. Simple. Okay? So now if I want to represent this as a source, how I will represent this as a source? I represent this as a current controlled voltage source. It can be a current controlled voltage source. It can also be characterized as voltage controlled current source when it is discharging, because the current through this is given by C dV by dt. Now if I want to know the current, I can know it through voltage. If I want to know the voltage, I can know it through the current. So at times, not at a time, at times, I can characterize this capacitor as a voltage controlled current source when I want to know what is the current out, and when I want to know what is the voltage charged, I can consider it as a current controlled voltage source. This is the meaning of dependent sources. Okay, this is the meaning of dependent sources. So this is very simple example. Just because already we know how the capacitor operates, I have taken this example. Okay, it is not always I want to characterize capacitor as a controlled source. No, I don't want to do that. I may not want to do that every time. Just to make you understand, what is dependent source. Dependent source is also known as controlled source. This is also known as controlled source. The source value is controlled by the parameter through some other circuit. And what is the value of IC here? Now the value of IC is depending upon the value of R. If I increase R, okay, the IC decreases when I am considering purely this branch. When I decrease R, IC increases. So the charge in the voltage across this capacitor is depending upon the current through this resistor, because the same current is flowing through the C, assuming this capacitor is ideal, zero internal resistance. Okay, so therefore the current drawn by this capacitor purely depends upon the resistance value or the current drawn by this resistor. So the voltage across this capacitor is depending upon the current through this resistor. Therefore the source value of this capacitor or this element depends upon the parameter through some other element. That is called dependent source or controlled source. Okay, so first we will see what are independent sources, how they are shown in the circuit. Okay, so independent sources. This is an independent voltage source. Okay. Okay. Alternating voltage source, or I can also represent it using the batteries. Okay. These are all independent sources. Okay, or independent voltage sources. This is independent voltage source. This is I. Okay, independent current source. So if the source values are represented in an element using the circle, okay, using the circle, these are independent sources. Okay, so independent sources represented using circle. Wherever you get circle, that is obviously an independent source. Okay, then what is dependent source? Or just need more space. Dependent source dependent source is represented using rhombus. Is represented using rhombus. Okay, if you get this kind of element, okay, it is dependent source. So whenever I am representing a dependent source, I have to always define a controlling parameter to that. Okay, I cannot say simply dependent voltage source. That voltage source is dependent on what? Whether voltage or current. Okay, so there are 4 types of dependent sources. Okay. First we will look to dependent sources. We will get dependent voltage source, we'll see dependent voltage source, dependent current source. Dependent voltage source, and this is dependent current source. Okay, now dependent voltage source is this. This is plus minus. So when I get plus minus terminals, that is voltage source. If I get a arrow mark, that is current source. This is well known. Now this is a dependent voltage source. No doubt it is a dependent voltage source. But this voltage value of this source is depending on what? Whether current or whether voltage? I don't know that. Okay. Now, if this is K into Ix. Okay. This is K into Ix. Then this voltage source is depending upon the current Ix. K is a constant. Okay. To that the current Ix is multiplied. Now what is this Ix? Ix is the current through some element in the same circuit. Current is the Ix is the current through some element in the same circuit, not in different circuit. It should be in same circuit. Okay. So it is a current controlled voltage source. It is a current controlled voltage source because the voltage value of this source is controlled by the current Ix. So current is controlling it. So it is a current controlled voltage source. Now there can be another voltage source, plus, minus. It is say some M into Vx or K into Vx, letter, whatever it is. K into Vx. Now, because this is, the across the terminal, this source or this element is characterized by voltage. Across these two terminals, it is characterized by voltage. Across these two terminals, it is characterized by voltage. Hence, it is voltage source. Now, it is confirmed that it is a voltage source. But the voltage across the terminal of that source is depending now on this voltage Vx. Now, what is Vx? It is the voltage across some element in the same circuit. Okay, it is Vx is the voltage across some element in the same circuit. And this is voltage controlled voltage source. It is voltage controlled voltage source. Okay. When there is plus minus, it is evident it is voltage source. Now I should be checking what is the controlling parameter. The controlling parameter is current. Here controlling parameter here is voltage. Okay. Now in dependent current source, now inside a rhombus, there will be an arrow mark, either upside arrow mark or downside arrow mark. Don't worry about the direction. Now this element is characterized by a current. Okay. Now let this be some element, some value L into Ix. Now again what? The value of this current source is depending upon the current Ix. Now what is Ix? Ix is the current through some element in the same circuit. Therefore, this will be a current controlled current source. Current controlled current source. Okay. Now, there can be a current source. Okay. There can be a current source L into Vx. So what is this Vx now? Now this Vx is the voltage across some element in the same circuit. So the value of current of this source is now depending upon the value of this Vx. Hence this is voltage controlled current source. Voltage controlled current source. Okay. So dependent sources are of 4 types. It can be a current controlled voltage source, voltage controlled voltage source, current controlled current source, voltage controlled current source. Whereas Vx and Ix, I will write Vx and Ix voltage across some element in same circuit. Ix current through some element in same circuit. In the same circuit is very much important. The circuit should be same. I cannot consider the controlling element or controlling parameter from something else or some circuit, some other circuit. Okay. So this is, or I will give you a small example. In dependent source, now suppose I have a circuit. Some circuit, okay, V1, R1, R2, R3, R4, R5, R6, V2. Now this is a controlled voltage source or dependent voltage source. This is dependent current source. So let this be 2 into Ix. Now this Ix may be current through R2. So this is a current controlled current source. Now here I will be getting 3 into Ix. Now that is current controlled voltage source. Okay. So this is the meaning of controlled sources or dependent sources. So today we will stop here with these sources. In the next class, in tomorrow's class, I will be looking into source transformation, how to convert a current source to voltage source to current source, and source shifting. What is the principle that I have to follow? If I have to shift the sources, I have to push the voltage source across the beyond the nodes, and if I have to take the current sources across the branches. Okay, so in next class we'll look into that. Okay, and if possible, the conversion of resistance connection, star delta conversion. Okay, these two things we will look in next class, and after that we will solve few numericals on this, and then we'll move to the mesh analysis and node analysis using KVLs. Okay, so today we'll end here. Thank you for joining the class.